let's try to find the frictional force for sand. Now this particular type of sand is from the Jersey Shore. Now it's interesting, if you look really carefully at it, you see different colors. You see pink, that's pink feldspar. Whites, generally white feldspar and quartz. There's milky quartz in there. There's the black. There's basically parts of granitic rock. There's a lot of granitic rock in this area, and when it gets eroded, it ends up in the ocean when the rain falls. So, and you see that they're sort of rounded, but sometimes angular. There's maybe some shell pieces in there too. We don't see that many shell pieces. Let's look at under a microscope. Let's look under a magnifying glass to see if we can see any. Oh, that doesn't help much more, but I see one piece of shell right there, but you can see there's pink, feldspar, white, a whole bunch of different things. And remember, these used to be part of rock in a mountain, and the rock gets exposed and it goes down. Now, some of them are smooth, but some of them aren't. And I'm going to put my block on top of it, and you're supposed to predict if the kinetic coefficient is going to be higher or lower. So what I'm going to do right now is just, all I have is 50 grams hanging off there right now. I'm going to see if 50 grams will make it move. And just by me, yeah. Oh, all right, so actually 50 grams then is higher than the static coefficient case. So to find the kinetic case, I have to go and use a lighter mass hanger. So I'm going to go and get a 5-gram mass hanger. And I gotta put it on the end of my string. So just to let you know, it looks like this. It's the one we used in the very first exercise. Let's go see how much mass. 5.2 grams. Okay, well, it doesn't really matter so much because I'm going to measure the total mass on the end of the string. So I'm going to hang it off there. So we know 50 grams was too much. Let's see, 5 grams. Nope. So the frictional force, I got to put more than that. I'm going to put 20 grams on here. And then I move it. Nope. I'm going to put another 20 on and push it a little. That's it. All right. So we're looking at kinetics for this so this particular exercise. So let's see what that is. 45.4 grams. So you can see, to find the frictional coefficient, it's 0.0453 times 9.8 meters per second squared. Compare that with the mass that was required to get, or the force that was required to get this thing moving in exercise number 1, and you see that it's lower. So believe it or not, some of you might have thought the sand would have increased it, but in this particular case, even though some of the sand is angular, you can see it moves around, and it moves. Some of them kind of roll a little bit, and it causes a little bit of less friction. Now, if they were glued down, and this is moving on top of it, then you'll see much different. But because these little particles can move, that means they act like little rollers, and it decreases the friction. So interesting enough. Now, sandpaper, we're going to do sandpaper, and you're going to see the difference between sand that can move and sand that can't move.